Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at transformer overcurrent protection sizing on the new release of Design Master Electrical for Revit. If you're attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. So in the new release, we added a new feature to customize overcurrent protection settings for transformers. Previously, we would size the transformer overcurrent protection to be 125% of the transformer size. And we got a lot of feedback from a lot of customers that the sizes we were choosing were not what their company standards were. We went back and forth with a couple different customers and discovered that everyone has a slightly different standard, generally based on some sort of a calculation, but usually shading some numbers one way or another, or just choosing numbers that they happen to like better. And so there wasn't any way for us to put in a calculation that was going to make everybody happy, or even options for calculations. So we added the new Transformer OCP Sizes command that lets you just tell us what the overcurrent protection should be for a transformer of a specific size. So in this dialog box, you have the voltage. So for each primary voltage, you can set a different overcurrent protection size for your transformer. Go ahead and take a look at the 480 volt. We have listed in the first column the transformer sizes. So those are the transformer sizes we're going to size for automatically. This also controls the list of transformers that will sizes that will show up automatically when editing a transformer. You can always set a custom size for a transformer, but this lets you set your defaults. We were trying to include a list of defaults, but different people kind of go down to different smaller sizes and larger sizes. So we decided to implement this to give you better control over what size transformers you typically use in your projects. So if you're never using anything small and you just don't want to see those in the list, you could actually get rid of these here, and then we're not going to see those smaller size transformers anymore. You can still, with the custom size, set it, but it's not going to show up in the pull down. And that pull down is over in the panel edit command. So if I run that and select this transformer for the sizes, you'll see that we've got the 3 and the 6, 9, but those smaller sizes we removed are not there. We then, for each transformer size, have the overcurrent protection for single-phase and three-phase transformers. So you just tell us, for a transformer of this size, what should the overcurrent protection be. And just as an example of why we implemented this, let's take a look at the 75 kVA transformer here. And that is going to have a full load amps of 90 amps, typically. Actually, if you do the math, it's 90.211 or something, if you go out to a couple decimal places. But typically, people call it 90 amps. In Design Master, we actually see that as 90.2 because we do the whole calculation and conversion with decimal points, and we don't round any of it. You multiply that by 125% to get the size of the overcurrent protection if you have continuous loads, and you get 112.75 amps. And so the question is, how big should that overcurrent protection be? Should it be 100 amps? Do you want to round down? Should it be 125 amps where you round up? Should it be 150 amps? I'm not totally sure of the basis of that number, but I've had customers who have asked for all of these sizes for 75 kVA transformers. And there is no way for us to figure out any sort of calculation. So now you just tell us, our company, we use 100 amps for a 75 kVA transformer, 125 or 150. If we take a look at a 150 kVA transformer, we've got a full load amps of 180 is typically what you would call it, but it's actually 180.4 or something. And if you multiply that by 125%, you get 225.5 amps. And since Design Master is not doing any rounding, we see that as larger than 225. So we are upsizing to a 250 amp overcurrent protection. Other people would want to just do that at 225 amps cutting off that half amp and assuming that 225 is big enough. Maybe you want to go down to a 200, or you've got at least one customer who asked for a 300 amp overcurrent protection. So rather than, again, try and figure out that calculation, we just let you type it in what it is. So you'll want to do this once for your company, set these values up in our overcurrent protection sizes. And then when you have them set in a project, you can either save that in a template, so open up a template and set all your values there, and then when you start a project from that template, it will use those values. Or you can use the export command to save those to a file, a text file that you can then read into new projects with the import command. So those are the two ways to save your overcurrent protection and all your other settings, and then reuse them in future projects. So you set it up once, and then either set it in a template or use the export and the import to use it on new projects. I see you've got a suggestion, which actually I have an answer for. When you've got a main lugs only panel, you want to do some if-then statements in the panel board schedule. We actually have implemented that. We use it for our one-line diagram purposes, but we're discovering it's helpful for people as well for their own purposes, because to do any sort of if-then statements, you need a numeric value. Yes, so it's DMEN panel main disconnect type, and it's a 0 for main lugs only, 1 for main breaker, and 2 for a fuse switch for the disconnect. So if I go to this MDP and I edit it from a main lugs only to a main breaker, that updates from a 0 to a 1. And you can then use that for your if statements, just like you said. We use that for our graphics. So that is currently a main lugs only. If I change it to a breaker, we put in that graphic automatically, and that's queuing off of that that same parameter. So we have that, and you can use that for your panel boards or anything else you need to do any sort of if-then statement on. The comment is that with an actual bus size, if you put in a smaller breaker, you get some numbers not being what you expect. So we do list the bus size and the main disconnect information all separate. So if we do edit that, so if it's a 150 amp bus, but a 100 amp breaker, it'll fill in the bus size with 150, but the disconnect is going to get 100 amps. And so you can use the disconnect type numeric value to do some filtering on that. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.